Hello, so today we're going to continue with solving systems of equation, but we're going to use another method, which is substitution. Now, here are the steps. The first thing you want to do is solve one of the equations for one of the variables. For example, you end up with x equals an expression or y equals an expression. The second step is you're going to substitute the expression from the step number one above into the other equation, and you're going to solve for the other variable. Now, we'll talk about that when we get to it, but step number three is you're going to substitute the value or your solution from step number two into one of the original equations, and you're going to solve for the other variable in step one. And last but not least, the last step is to write your solution as an ordered pair in the form of the ordered pair xy. So let's go ahead and well, before we do the problem, these steps are on page 237 in your textbook. Again, Go Math textbook, page 237. So let's look at the first problem. The first problem, we have an equation, a system that has the equation y equals negative 5/3 x plus 3 and y equals 1/3 x minus 3. Now, the first step is to solve for one of your variables, but you can see that it's already solved for the variables y, each equation, and so what we're going to do is we're just going to substitute one of the equations to the other, and you end up with an equation in the form of an equation of negative 5/3 x plus 3 equals 1/3 x minus 3. And so here we have an equation. This is the unit we just completed, and so you're going to use friends don't come in algebra match-em. First thing you do is distributive property. No, you have fraction busters. The least common multiple is 3, so you're going to multiply everything by 3, and that's going to give you negative 5x plus 9 equals x minus 9. Now I'm just going through these fast because this is review, and I don't want to make this video way too long for you guys. Next thing you do is isolate the variable terms. That gives us 9 equals 6x minus 9. Undo our constant, and then we go ahead and undo multiplying, dividing. So we end up with the solution of x equals 3, and that's going to be our x value in the ordered pair of our solution. Now what we want to do is we want to take that x value, and we're going to substitute it into one of the equations. And I'm going to use y equals 1/3 x minus 3. So instead of y equals 1/3 times x minus 3, it's going to be y equals 1/3 times 3 minus 3. So then you have you multiply before you subtract using the order of operations, and we end up with y equals 1 minus 3, which is y equals negative 2. So our solution to our system is going to be the ordered pair 3, negative 2. Now you can go ahead and substitute these into both equations to determine whether or not your solution is correct. But for the sake of time, trust me, it is correct. Let's look at the second type of problem here. In this type of problem, you can see that only one of the equations is solved for y. So we're going to go ahead and use that expression, 6x minus 11, and we're going to substitute it into the other equation. Instead of negative 2x minus 3 times y, it's going to be negative 2x minus 3 times the quantity of 6x minus 11, and that's going to equal negative 7. So here we have an equation again. Friends don't come in algebra match-em. We don't have any fraction busters, but we do have distributive property. We're going to multiply negative 3 times 6x and negative 3 times negative 11, and that's going to give us negative 18x plus 33. And we bring it down, bring it down, bring it down, bring it down. Next, we combine our like terms. We got 2x minus 18x. That's going to give us negative 20x plus 33 equals negative 7. And by now, we should pretty much know what we're doing. And so we end up with the solution of x equals 2. Now I have to switch up my markers because it is kind of hard to read the numbers. So our x value in our solution is going to be 2. So now we want to take that x value and substitute into one of the equations. I'm going to go ahead and substitute into the first equation because that's the easiest one. So instead of y equals 6 times x minus 11, we're going to take y equals 6 times our solution of 2 minus 11. And so we multiply before we add or subtract, and we end up with the solution of the ordered pair 2, positive 1. Number 3 is a little bit different. As you can see, there is no equation solved for either x or y. But if you look at the coefficients for every term, you see that the y has an coefficient that is positive 1. So that should give you a clue that we want to eliminate negative 5x and solve for y. And so we're going to take that equation and we're going to add 5x to both sides. When we add 5x, that's going to isolate the variable y, and we're going to end up with an equation of y equals 5x minus 3, which is equivalent to that original equation. Now we're going to take that original value of y, just like we did on the last problem, and we're going to substitute into the other equation. So we're going to use the equation 3x minus 8y, and we're going to substitute the expression 5x minus 3 and substitute it for y. So instead of 3x minus 8 times y, it's going to be 3x minus 8 times the quantity of 5x minus 3, and that's going to equal 24. So we're going to use the distributive property, and so then we're going to combine our like terms, and then we're going to isolate the variable terms. We don't have to isolate the variable term. We're going to undo adding or subtracting of a constant, and we end up with a solution of x equals 0. So remember, 0 is a solution. Don't be scared when you see a solution of 0. And so now we're going to take our solution of x. That's going to be our x value in our solution, the ordered pair of our solution. And now we're going to substitute into one of the equations. And again, I'm going to use the first equation because that's the easiest one in my opinion. So instead of negative 5 times x plus y equals negative 3, it's going to be negative 5 times 0 plus y equals negative 3. We multiply, because that's distributive property. We end up with 0 plus y equals negative 3, and we end up with the solution of y equals negative 3. So we take that value of y, and we plug it in or substitute it into our solution, which is the ordered pair 0, negative 3, with the corresponding x and y values based on what we just solved. Now the last type of problem that we're going to have is a little bit more tricky. Here we have, if you look at our coefficients for our variables, none of them equal positive 1. So this is going to take a little bit more work. So basically just choose one of the equations, and I'm going to use negative 5x minus 8y equals 17, and I'm going to go ahead and solve for x. Now how do I solve for x? Well, I need to undo negative 8y. How do you undo negative 8y? You add 8y to both sides. So that gives us an equation of negative 5x equals 8y plus 17. Now, since x is being multiplied by negative 5, we got to divide both sides by negative 5. So we got to divide every term on both sides by negative 5. Negative 5x divided by negative 5 is x. Negative 8y divided by negative 5 is going to be negative 8/5 y. And then positive 17 divided by negative 5 is going to be negative 17/5. So here we solve for x, and now we need to take that value, and we need to substitute into the other equation. So we're going to use the equation 2x minus 7y equals negative 17. So instead of 2 times x minus 7y equals negative 17, it's going to be 2 times negative 8/5 y minus 17/5, because we are substituting the expression that we solved for x. And because we are multiplying 2 times x, I like to highlight or box it because a lot of people forget to bring down the other variable term, which is negative 7y. And so we end up with this equation here, and then we follow the steps of don't come in algebra matchup. We're going to go ahead and distribute. 2 times negative 8/5 y is going to be negative 16y fifths. 2 times negative 17/5 is going to be negative 34/5. And then we bring it down, bring it down, bring it down. And next thing you do is we have fraction busters. So we're going to multiply by the least common multiple of 5. And so we need to distribute the 5 to the 3 terms. Some of you guys on the quiz messed up because you forgot to multiply every term by the least common multiple. So let me go ahead and simplify that for the sake of time. And then we're going to combine some like terms. We have negative 16y minus 35y. That ends up being negative 51y minus 34. And that's going to equal negative 85. And then from here, we undo adding and subtracting of our constant term. And then we undo multiplying or dividing of a variable term. So we end up with the solution of y equals positive 1. That's going to be our y value of our solution of the system. And so we're going to end up with a solution of the order pair something y, which is going to be something 1 because y equals 1. So let's go ahead and now take that value of y and substitute into one of the equations. And in this case, it doesn't matter which one, but I'm going to choose the first one because to me that seems a little bit easier. So instead of negative 5 times x minus 8 times y equals 17, it's going to be negative 5 times x minus 8 times positive 1, because y equals 1, equals 17. And so now we have an equation, distributive property. We're going to multiply negative 8 times positive 1. That's going to give us an equation of negative 5x minus 8 equals 17. Undo adding and subtracting of our constant term. And then we're going to go ahead and undo multiplying and dividing of our variable term. And we end up with the solution of x equals negative 5. And that's going to be our x value in our order pair. And so the solution of this system is going to be the order pair negative 5, positive 1. Now ideally we would take those values and substitute them into both equations to check our solutions. And I showed you guys that during class very quickly. But I just wanted to give you guys a quick wrap up of today's lesson of solving systems of equations by substitution. And I hope you guys enjoyed the video. Make sure you guys do any homework, any questions, please come see me. You guys have a good day.